Alright guys, so today we are looking at counting principles, okay? And we're looking at permutation and combinations. Well, let's use an example, okay? How many ways can 3 books, okay, with different titles be arranged in a shelf, okay? So, we are counting, we are looking at arrangements, okay? So, imagine that we have the book, the name of the first book is A, B, and C. So there are 3 books and we want to arrange them. We can take the first book, the second book, and the third book, or maybe choose the first book and switch the position of the second and the third. Okay, we can take the second book first and then take the last book and then the first book. Okay, so we can do this arrangement in the form ABC, ACB, BCA, BAC, CAB, and then CBA. Okay, so there are 6 different ways of arranging 3 books in a shelf. Okay, 6 ways. Okay, that's manually. Okay, look at the combinations we did over here. Okay, we are taking all of them at a time. Okay. Now, if you are asked to arrange, what if you are asked to arrange 5 different books? Only 3 of them is 6 way, 4 will be 24 ways, okay? So 3 is 3 times 2 times 1, okay? And then 4 will be 4 ways. So we use the factorial method to do that. So when we had 3 books, we had 3 times 2 times 1 is 6, right? When you get 4 books, it will be 4 times 3, which is 12 times 2, which is 24, okay? So what if you are asked to arrange 10 books? So the process continues. This will be 120. So you see how the number jumps. What if they are asking you to arrange 100 books? Okay, it's difficult to do it manually. So you use n factorial, okay? So this is the n factorial. What you do is that you take the number and then reduce it by 1 until you get to 1 itself, okay? That's the easiest way of doing that, okay? Now, we have Mississippi problems, okay? There are certain times that when you are arranging, okay, if you want to arrange, this is Mississippi. If you want to arrange, some of the numbers are not distinct. You see, in the first case, we have different books, maybe A, B, C. We have these letters, and we are choosing all of them. What if the A is repeating? We have AA, okay? So if they are not distinguishable, okay, not distinguishable, what are we supposed to do? So this is what we do when they are not distinguishable. So imagine I'm supposed to arrange this book, and the title of the book is AA, and BBB, then C. These 2 books, we cannot distinguish them which position we put them, okay? So if I put A here and A here, now if I switch the position of this one to AA, it's the same thing, okay? So it means that no matter how much arrangement I do, this will be the same as that, even though I switch the position of A, because the books have the same title, okay? So the books have, so I have AA, the position is AA. Now, the second arrangement, if I bring this A here, I don't change anything. So what we do is that, for us to do it distinguishable, okay, the solution to this in arranging these books, which have these have the same title, these 3 has the same title. So you count a number of books that have the same title. In this case, we have 2 A's. Okay, so we have 2 of the A's. Then here we have 3 B's. Okay, so the solution to our problem, normally in our first case, we would have just count 1, 2, 3, 4, 5, 6. Then we write 6 factorial. But that will not be the case now because we have to divide by the same repetitions. Okay, so our solution will be 6 factorial divided. Okay, this is a division sign by 2 factorial and 3 factorial. Where did I get the 2 factorial and the 3 factorial from? They are from this one because they are repeating. The books are having the same titles, okay? And then the 3 factorial is coming from how many B's are there, okay? Now, Okay, now let's go to the reason why these problems are called Mississippi problems, okay? The reason why they're called Mississippi problem is because Mississippi has a lot of letters that are repeating among them. So if we have to arrange these letters, okay, we have 4X, okay, and then there are 4 I's in the Mississippi, and then there are 2 P's, okay? So in this arrangement, okay, we just use the example we had before, okay? So there are 4 I's, there are 2 P's, and there are 4 X in Mississippi, okay? So our solution will be 11 factorial, okay? The letters in the Mississippi, when you count, let's go back and see. When you count, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 factorial divided by 4 P's, which is 4 factorial, okay? 2 P's, which is 2 factorial, and then 4X, which is 4 factorial as well. Okay, so in this point, if you already said the question this way for me, most of the time, if I'm grading you, I'll give you the full grade over here. But if you go on and you do the calculation for the factorial, I will also give you the full mark, okay? Because this is a lot of numbers, okay? Now, we are now looking at permutation. Okay, so we have come to permutation. So, assuming that there are 15 people in my AP statistics class, and we have to choose only 4 of them for first position, second position, third position, and then the 4th position. We are choosing for 15 people here, 15 students to be precise, okay? 15 students, and we are choosing first position, second position, third position, 4th position, okay? And there are 15 people competing for that position. This is how we solve that question. Now, the number of ways of doing that. For the first 15, okay, 15 people will be fighting for the first position. Okay, they will be competing. Now, if the first person gets this position, one of the 15 gets it, then it's left with 14 people who will be fighting for the second position. So that's why it is 14 over here, okay? So this is for the second position. This is for the third position. Now, if out of the 14 people, if one of them win the second position, now there is 13 people who will be competing for the third position up to the 4th position, where only 12 people will be competing for it, okay? So, in fact, in permutation, okay, we are looking at the order at which things occur. So the order occurs first position, second. So order matters in this. So here, the order at which it occurs matters a lot. Okay? But if you want to write it, you just do 15P4, okay, which is permutation 4. So this is how we write it, which is 15 factorial divided by 15 minus 4 factorial. Okay? And this will give you the same answer we got over here. So this is practical way of looking at it, but this is the formula. Okay, the formula says that if I have 15 people and I'm choosing 4 of them where order does not matter, okay, this is how I write it: 15 factorial divided by 15 minus 4 factorial. Okay, and then the formula is, so I have 15 people, n people, and I'm choosing r of them where order does not matter. So it will be n factorial divided by n minus r factorial. Okay. So basically that is what permutation is about. Now we go to combinations. Okay. Combination is a little bit different. The formula for combination is I have n things and I'm choosing r of them. But here order matters a lot. So to be n factorial divided by n minus r factorial. So with the same problem we've had, okay, assuming that I'm choosing 4 people and I don't mind which position they are in, then I use combination because order does not matter. Okay, if order does not matter, okay, all we do is that 15 choose 4 will be equal to 15 factorial. Okay, remember, here order does not matter. I don't care which position, I'm just choosing 4 people. So it will be 15 factorial divided by 15 minus 4 factorial and 4 factorial. The answer for that will be 1365, okay, which is 1365, okay. All right, so that's pretty much it. I'll be putting the notes there. You read the note and I'll type all of these examples in there. Okay, if you don't understand something, let me know. I'll be those of you online, be checking out. I'll be having a Zoom meeting with you so that I can attend to some of the problems you have. Okay, until then, watch out for the next video tomorrow. Okay, bye.